Hello everyone. Today we're going to introduce you the libraries and components for hydraulic modeling in SimCenter MSim. Our learning objectives are to have a brief overview of hydraulic modeling and available libraries, and also get familiar with HYD library and its components. So there are three main libraries that can be used to build hydraulic system or hydraulic component models, depending on your simulation objective. There are hydraulic library, HYD, hydraulic component design library, HCD, and hydraulic resistance library, HR. Why there are three different libraries for hydraulic system modeling, depending on your modeling or simulation needs. For example, if you're going to analyze the system behavior or dynamic response when the pump speed is increased from 1000 RPM to 2000 RPM, we want to check the pressure change at different locations and flow rate at different branches. Then you need to use HYD library to build up the complete hydraulic circuit and check the results by performing a transient simulation. The components from this library, such as pump, motor, valve, hydraulic jack, and so on, are all defined by their characteristic curves or data table, where you can get from the suppliers. Compared to HYD library, the hydraulic component and design library is used to focus on component-level modeling tasks. For these HCD components, it is the geometry information and physical properties are governing the calculation, instead of characteristic curves or data table used in components from HYD library. The last one is HR library. From the words you may already know, it's designed for calculation of resistance in hydraulic circuit, namely pressure losses. Especially in some large and complicated hydraulic networks, we need to focus on pressure loss and flow distribution calculation, where you have to take into account the bands, expansion, contraction, bearings, and so on. These components are available from HR library for you to build hydraulic network models. Here is a snapshot of all components in HYD library, and on left-hand side is a simple hydraulic system model built from HYD components. For HCD library, you can see a detailed fuel injector model created based on this library. And here we see the HR components, and they can be used to build lubrication circuit model, for example, as shown in the left figure. From this slide, we will introduce a bit more HYD library, as this is the main library and can be used almost for all hydraulic applications. Plus, the other two libraries will require many components from HYD library. First things first, before creating any hydraulic circuit or component model, a fluid icon needs to be placed for the very first step, because you need to define the fluid properties, or in another word, which fluid is supposed to flow inside the circuit. Then, as boundary inputs to the models, several pressure and flow rate sources are available to be imposed into the circuit model. The virtual sensors components are to be placed in the model to send out the pressure or flow rate signals for further use. Now you can start to build up the hydraulic system model from scratch, according to the schematic if you have any, starting from pumps to different nodes, then connect with orifices, chambers, and pipes, in the end to the tank. Also, you can find some functional models of valves and actuators in HYD library. For a quick evaluation of hydraulic model behavior, these components are easy to parameterize, no need to collect many geometrical dimensions and physical parameters such as spring stiffness, preload, for instance. Okay, now we have finished the introduction of three hydraulic libraries. Here are some important points to keep in mind. With this, we end our lesson on libraries and components for hydraulic modeling topic.